Hi viewers, I am producing these videos to help teachers of maths support their learners in making sense of mathematical concepts and their associated procedures and processes. And today I want to look at the short version of the column multiplication algorithm. And so to do that, I'm going to use the Dean's blocks to help me work with that, although you can use place value tiles as well. So let's have a look at a multiplication. Let's say I want to look at the multiplication 124 times 6. And we can see that I've set up the number 124 over here using my deans. So the way that the column multiplication algorithm works is generally around a sort of repeated addition idea of multiplication. So the idea is I am going to repeatedly add each of these ones, tens, and hundreds in turns. And the reason I'm going to do it in that order is because if I repeatedly add a lot of ones, then I may well end up in the position where I'm going to need to exchange some of those ones for tens. And then similarly, if I repeatedly add some of these tens, I may well be in the position where I have to exchange some of those tens for hundreds. So I'm going to start with having 4 repeated 6 times. So here is my 4, and I'm going to repeat that. So that I have 6 of those, the product of 6 4s. And I can see that actually, if I take some of these, I can, let's take it from the bottom, I can create some 10s. So that is 4, 9, 10. So I can create this 10, which I can then exchange up for an extra 10. Well, it wasn't that one, but I can exchange it up for an extra 10. Now I'm just going to pull that out of the way for a minute. And then what I should be able to do, all being well and good, is do another one. There we are. So I'm just going to pull those out of the way a minute. So by the time I've done that repeating and then exchanged, what I find is I have 4 ones, and then I have 2 extra 10s, which I don't have to multiply, but I am going to have to collect with my other 10s later on. Okay, and that's of course coming from 6 times 4 being 24. So I had 24 ones there initially, and I've exchanged 2 sets of 10 ones into my 2 10s. So now I'm going to do the same thing with my 10s and say, right, okay, well, I am going to repeat that 6 times. So 1, 2, 1, 2. So that's 3 repeat. I've got 4 sets of 2 altogether. Now I've got 5 sets of 2 and then 6 sets of 2, keeping those well out of the way for a minute. And then again, because of the number of 10s I have here, what I should be able to do is exchange them up. And we can see I've managed to exchange them up for an extra 100, which again, I'm going to keep out of the way for a minute. But what I've done there is said, right, so repeating 2 10s 6 times has given me 12 10s in effect. But I've exchanged 10 of those 10s for a single 100. So what I've got now is 2 10s left. I've got 2 10s left from there, plus now my original 2 10s I got from the exchange. So what I have now altogether is 4 10s. And then I've managed to get an extra 100, which I'm going to keep out of the way because I don't need to multiply it, but I will need to exchange it for my other, I will connect it with my other hundreds later on. And then finally, I have my 100, which again is going to be repeated 6 times. There it is. And as well as having those 600, I have my extra 100 from before. So now I have a total of 700s. So what I have now is a total of 700, 40, and 4. And so you can see how using that repeated addition model, we can show why we're getting these sort of extra tens and extra hundreds that we're not going to have to multiply, and that's why we dragged them out of the way, but that we are going to have to repeat, collect once we've multiplied what we actually started with. Hopefully that's all clear and that all makes sense. And hopefully that will go some way to be able to allow you to support learners in making sense of this particular algorithm. As always, I'd like to say a big thank you to mathsbot.com and its creator, Jonathan Hall, for providing this wonderful website, which houses not only all of these virtual manipulatives, but a wealth of teaching materials aside. And if you've not been to mathsbot.com before, then you really do need to go and take some time to get in there and have a look at all the wonderful free things it offers to support teachers of maths working with their students. And if you're interested in using manipulatives and visuals to support making sense of maths and helping learners make sense of maths, then please do check out my website, visiblemaths.co.uk, where amongst the many things you will find on there, you will find a link to my book, Visible Maths. And that link is to the publisher's website. The publisher is Crown House Publishing, and they have some sample pages on there which you can have a look at. And if you feel like it might be useful for you, then you can, of course, place an order. I'll be making these videos throughout lockdown. So if there is a particular process or concept that you feel like you'd like to see me explore with manipulatives or visuals, then please do get in touch and I will do my best to produce one for you. Thank you very much for your kind attention.